Wheatstone bridge. Now we are going to consider four resistors R1, R2, R3 and R4. They are connected as shown in the circuit with a battery of voltage V only. The current is going to be flown in this direction from I, and A is a junction, so it is going to be divided into two parts, I1 and I2. I1 is going to be flown from R1. Here we are considering galvanometer between point B and point D. The same current is going to be flown from the R2, and I2, R3, R4, I2, and again back to point C. It is I1 plus I2, that is I. Now we are going to consider two closed loop. According to Kirchhoff's second law, for the loop, the resultant potential is going to be zero. So we are going to consider one first loop A, B, D, and back to A. So for that loop, first minus I1 R1, because the current is flowing in the same direction of the loop only, that's why minus I1 R1 plus I2 R3, that is equals to 0. And for the second loop, C, B, D and C, I1 R2, because current is in opposite direction to the loop, so plus I1 R2, that is equals to or minus I2 R4, that is equals to 0. Now we are going to just simplify them. I2 R3, that is equals to I1 R1, so we can say that I1 by I2 is equals to R3 by R1, and I1 by I2, that is equals to R4 by R2. So we can say that we are going to compare both these equations. So R3 by R1, that is equals to R4 by R2. And if we are rearranging that equation, we are going to have that R1 by R2, that is equals to R3 by R4. So from this condition we can say that if this condition is going to be followed, that R1 by R3, that is equals to R2 by R4, the net current flowing between point B and point D is going to be zero. That is the very important outcome of the Wheatstone bridge.